All right. Want to continue with the trend of accuracy and efficiency. Okay, we're working on both of those skills. But not only do we want to be able to solve it, we want to be able to do it quickly. The SAT has an average of 2 minutes per question. Most of the questions have multiple approaches that you could use to get to the answer. But if it takes you 3 minutes to solve it, well, now you have a minute less on another question. So again, paying attention to the patterns and the structure within the different types of questions will allow you to solve them much more efficiently. With systems of equations, a lot of students like to prefer going straight to the graph. Let me just graph them and see where they intersect, okay? Which will get you the answer, but many times is actually going to take you longer to get the solution. If they want you to use the graph, they're actually going to provide the graph. If they don't provide the graph, there's another way to get there. Now, if you need the graph, if you genuinely need the graph, then you do, but just be aware that you may have to sacrifice some time somewhere else to make up for the time lost on that. Okay, so if they want you to use the graph, they're probably going to provide the graph. Now, the solution to a system is the intersection of the points. It is always an ordered pair. Whether or not they care about the whole ordered pair or they want you to do something with that ordered pair, that's a different question. We're going to focus on the skill of solving these. And at the end, I'll show you an example of how we wouldn't necessarily use the whole ordered pair. Okay? But they may say, solve this system, A and B are the X and Y coordinates of the system, find the value of A plus B. Okay, so instead of finding the numbers or just finding the numbers, you would then find the numbers and add them together. So they may have an additional task kind of tied into that. Okay, so I may have this system here and they'll say that A and B are the ordered pairs. What is the value of A plus B? And that's that would be like a free response question. That would be a fill in the blank instead of multiple choice. So then you have a number you can type in, 5 being the sum of the two coordinates. Now with the system, we have two algebraic processes depending on what the structure of the system is. Substitution is typically going to be easier if the variable is already isolated or almost isolated. In our first example, x is already by itself. This is set up for substitution, ready to go. In our second example, none of our variables are isolated, but I could really quickly get y isolated. What would I have to do? Add 3x, right? If I add 3x, boom, y equals 3x plus 7, and I'm ready to go for substitution. I can go ahead and apply that method, okay? So if x is isolated, if one of the variables is isolated or very, very close to being isolated, substitution is often going to be faster. If not, then typically elimination is going to be our best bet. Elimination is great when all of our coefficients or all of our variables have a coefficient. If every single variable has a coefficient, typically elimination is going to be a cleaner process. Especially when two of the terms are the same or opposites, because then we could either subtract or add the equations together to eliminate that variable. Or if one equation has a term that's a multiple of the other. So 2y and 4y are not the same, but if I multiply this equation by 2, well, then now these are the same, and I can subtract the equations to eliminate the variable. Okay, So looking at the structure to see which one is easier. And I got curious last year, and I went and I asked all the math teachers around here, and for the most part, we all have the same preferred method. 90% of the time, we use elimination, unless substitution is just blatantly easier. Okay? Most of the time, we default to elimination method because it tends to be a cleaner process than substitution. Okay? So we're just going to do 2 examples of substitution, 2 examples of elimination, and then we'll kind of talk about structure and solutions regarding slope. So we should really only be using substitution when isolate is pretty much already done for us. We want one variable by itself. So if we've got that, then we should be using substitution. All right, or we can get there in just one step. If it's going to take you more than one step to isolate a variable, don't use substitution, just use elimination. We will substitute one expression into the other equation. This will leave us with a one variable equation, and this is really important. We should only have one variable so that we can solve for the variable. This last step will vary depending on what they want you to do. Sometimes they'll just say, you know, we have the solution. There's the following system has one solution. What's the value of the y coordinate? And if they're just asking for the y coordinate, then you just need to find the y coordinate. I don't care what the x coordinate is. Just find the y coordinate. If I want the whole ordered pair, then I need to make sure that I get the whole ordered pair. So make sure you're reading the instructions for what the question's asking for. But if we need the whole ordered pair, we can substitute one variable back in to solve for the other. So we look and we say, all right, do I have a variable isolated? Yeah, which one? Y, on the left. Okay, y equals 3x minus 1. So I can take the expression 3x minus 1 and I can substitute it in for y into the other equation. I can now replace this y with that whole expression. So now what's my new equation going to be? 8x. Okay, so y was replaced with a new expression, and then we solve. Combine like terms. What's up? Yeah. What do I have now? 7x minus 1 equals negative 8. 7x equals negative 7. X equals negative 1. Okay, are we done? No. Now we need to find the y. So I need to plug this variable back into either equation. Doesn't matter which one. Which one looks easier, left or right? Left? Cool. Y equals 3 times negative 1 minus 1. Y equals negative 4. Okay? So then what's our final solution? Negative 1, comma, negative 4. Okay? An ordered pair. It's a point on the line. It's a point that exists on both lines. Do I have a variable isolated for b? No. Can I get one really quickly? Yep. Which one would be the fastest to isolate? The x on the first one. Okay? So I can rewrite this to be x equals what? 2y minus 2. Now we substitute in. Here we're going to substitute in for x. So I have 7 times 2y minus 2 minus 3y equals 19. Now what? Multiply. 14y minus 14 minus 3y equals 19. 11y minus 14 equals 19. 11y equals 33. y equals 3. Are we done? Nope. Drop back in. Left or right? Left again? Cool. X minus 2 times 3 equals negative 2. X minus 6 equals negative 2. X equals 4. My final solution is 4 comma 3. Okay. Be careful. We solve for x second, so make sure it's still the first coordinate in the ordered pair. Questions on substitution? Okay. So elimination, sometimes called the addition method or the subtraction method, the goal is eliminating a variable by either adding or subtracting the equations. So we want to identify a variable where the coefficients are the same magnitude in each equation. So either they're the same value or they're opposites. Same value or opposites. Then we can add or subtract the equations. This should get rid of one of the variables, leaving us with a one variable equation left to solve. And that equation is usually just going to be a one-step problem. You just need to divide to figure out the value. Then, just like in substitution, we plug it back in to find the rest of the coordinate. Okay. So we want to stack this up like old school addition. If I were to add or subtract these expressions, would one of my variables cancel out? The y. If I go ahead and add these together, negative y plus y equals 0, that eliminates. So then I add my x's together, 5x. I add my constants together, x equals, see how clean that was? Okay, now what? Okay, do we want to use left or right? The right one? Cool. Again, that's the efficiency part. Either equation works. Look to see which one is going to be faster, which one's going to be efficient. Save you those extra seconds. Ones that you can use some mental math, right? I'm writing out these steps, show, how we get from A to B to C. On the SAT, if you can do the math mentally, do the math mentally, okay? It's a time test. You don't have to write everything out. No one's checking your work on the SAT. Bubble it in, okay? But being able to understand what's going, what path is going to be the most expedient, really important. That a key component of that critical thinking and problem solving. How did I get this 2? So we take this 3, substitute it back in. 2 times 3 is 6. We subtract 6 from both sides. Y equals 2.
So that's everyone works for each.
Say that one more time.
I mean, like elimination works.
Both methods will work for everything. It just depends on how much effort is it going to be to set it up so that it works. Okay. So for example, let's see. So like all these actually work out pretty. You could do either one, and it's not too painful. But for example, oh, you know what? This would be fine. Okay, for this one, for these examples up here, trying to use substitution method and isolating one of the variables on any of these is always going to leave me with a fraction. I'll still be able to get the right answer, but now I have to do all my math with some extra fractions, which takes more time and effort and more cognitive load, rather than using elimination so that I don't have to deal with the fractions. Okay, so that's kind of the difference. Both of these will always work. It's which one is going to be the the cleanest process of solving. Does that make sense? So if you don't get hung up on which one should I use if you can't see the difference, but as you're working on your assignments and you're doing the different practice problems, take a few minutes now in this time to think, okay, which is going to be easier? Is it going to be easier to do substitution, or is it going to be easier to do elimination? Does that make sense? Okay. And like on your homework assignment tonight, a few of them will say solve using substitution, solve using elimination. Take a minute to look at the question and ask yourself, why is it suggesting that I use this method? What about the structure indicates substitution might work better or elimination might work better? Does that make sense? Okay. Now, if I were to stack these, wow, that changed color mid-writing. That was cool. All right, if I were to stack these and either add or subtract, would any of my variables cancel out? No, not as it is, so I need to change one of them. What variable looks like it'll be the easiest to eliminate? The y. So which of these equations do I need to change so that I can cancel out the y? I need to change this bottom one. What do I do to it? Multiply it by 2, okay? So in order to get the y's to cancel out, I can multiply this equation by 2. That's going to leave me with 8x equals 12. Okay? Distribute, 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 multiply the whole equation by 2. So now, if I add these equations, the y's will cancel, and then what are we left with? 22, okay? 3 plus 8 gives 11, times 12 gives me 22, so x equals 2. Let me plug it back in. Left or right? Which one? Right? 4 times 2 minus y equals 6. 8 minus y equals 6. Y equals 2. So we have negative y equals negative 2, y equals 2. Okay? So we have our solution of 2, 2. All right. Questions on either of those? All right. Oh, I forgot to erase this. Hold, please, while we backtrack. All right. So intersections and numbers of solutions. Linear equations, as long as my lines have different slopes, they'll intersect at one point. And that's the solution. In our next unit, later on, we will have nonlinear systems. So maybe I'll have a quadratic or a cubic or some other function and a linear equation. And so we may have more than one solution. But if we're dealing with a linear system, 2 lines, different slopes, are going to intersect one time, one solution. If I have 2 lines with the same slope, what kind of lines are those? 2 lines with the same slope.
Parallel.
Not perpendicular, parallel. Okay? Parallel lines. And parallel lines never intersect. If they never intersect, then I won't have a solution to the system because they have to intersect to have a solution. And then if I have 2 slopes, 2 lines with the same slope and the same y-intercept, that definitionally makes them the same line. So if they're the same line, then they have an infinite number of solutions because they completely overlap. So every point on that line is a solution. Okay? Don't confuse it with all real numbers. It's not the same thing. Okay? Because all real numbers would be all solutions to everything, every ordered pair. And it's not every ordered pair, it's just the ones on the line. There's a lot of them, but it's not everything. So again, considering what the question's asking for, does it say solve the system? No, it's just asking how many solutions. So you're either going to say one, none, or infinitely many. And we have to look, all we have to do to determine that is we start by looking at the slope. How does the slope of these two lines compare? I see where you say that, but this isn't in slope-intercept form, right? Isa, what were you saying? Why are they equal? How do you know? We isolate y so that it's in slope-intercept. That cancels. We get x plus 6. So they have the same slope. What about the y-intercepts? Are they are also the same. So these are the same line. So how many solutions do we have? Infinitely many. We have infinitely many because they are the same line. So one of them was in slope-intercept, the other one wasn't. We needed to rewrite and compare the slopes first to figure out whether or not we have a solution. If we compare the slopes and we see that they're different, we're done. One solution. Doesn't matter what the y-intercepts are. So what about B? How many solutions? It's not infinite. Why 1? Slopes are different. One's positive, one's negative. Different slopes. So one's going up and to the right, one's going down and to the right, so they're going to intersect somewhere. So they have one solution. Do I care what that solution is? No. Doesn't ask for it. Just says how many. I have one. One solution. Yeah.
I have a question.
The rate of change. Rise over run. Now, this is a classic SAT style question right here. Because you have no way of finding what the solution is. So you have to be able to reason through and understand what is the relationship between systems and the number of solutions. So they tell us that this system has no solutions. So what does that tell us about these two lines? They have the same slope. They are parallel. No solutions means that these two lines are parallel. So they want us to find the value of A divided by B. A and B are some unknown constants. Okay? A and B are positive constants. All right? So we know these are parallel. So we know that they have to have the same slope. What could I do to these equations so that I could then compare the slopes? I don't want to eliminate y, because that would let me compare the x-intercepts, but I wouldn't be able to find the slope, because I don't have any values for a and b, so there's nothing to calculate there. Yeah, we could put it in slope-intercept form, right? That's an easy way to compare the slopes, okay? Get it in the slope-intercept form. We're not going to know what the slope is, but we'll have a comparison. So I want to take this first one. I want to put it in slope-intercept. What's the first thing I'm going to do? Okay, so which one are we going to move? We're going to move ax, the whole term, right? So negative 3y, negative ax, plus 21. And then divide by negative 3. Bam, bam, bam. Negative 3, negative 3, negative 3. So y equals a over 3 x, and then intercept doesn't matter because we already determined that we're just trying to compare the slopes. I don't give a crap about the y-intercept, just focusing on the a over 3. Okay, so the slope of the first line is a over 3. What about the slope of the second line? Say again. So we got b over 3 x and then whatever the intercept is. Again, I don't care about the intercept. All I care about is the slope. Okay, so we've got the slope, or at least expressions for the slope. What's the slope of the first equation? A over 3. And what's the slope of the second equation? B over 3. And what did we say about the slopes has to be true? They have to be the same, right? A and B are going to be positive integers, but the slopes have to be the same. So given this comparison, that A over 3 and B over 3 have to be the same, what does that tell us about A and B? They have to be equal. The only way for that equation to be true is if A and B are the same value. So if A and B are the same value, what does A over B have to equal? 1. If A and B are the same number, pick any number, divide it by itself. It is always going to be 1. Now that was a long, convoluted way to get to 1, right? So I'm going to show you a shortcut. I'm going to show you a secret structure hidden within standard form, because when they want you to compare slope in systems, I've rarely ever seen the equations in slope-intercept form. They're typically in standard form. And to waste your time, they want you doing this, okay? But you don't have to do this. I'm going to erase all of this, and we're going to look at it slightly differently, okay? We did 2 things to convert it to slope-intercept form. What were those 2 things? Okay, we subtracted the x term, and then we did what? Divided by -3. The only things I cared about to find my slope is I needed this coefficient and this coefficient. The opposite of this number divided by this number, that was my slope. That's the structure within standard form. If you want your slope, it's the ratio of your coefficients. You just have to switch the sign because you got to remember you're moving it to the other side of the equation. So the opposite of the x coefficient divided by the y coefficient, that gives you your slope. So I know that these are the values that relate my slope together, right? And then I look at the system and I say, okay, well, these ratios have to be the same. In order for the slope to be the same, the ratio of this to this, okay, a to -3, has to be the same as the ratio of b to -3. And so I say, okay, well, these 2 things have to be the same, these values. That means that these have to be the same, and these have to be the same. Well, these are already the same. So A and B have to be the same. That's the whole process. All right, the ratios have to be the same, which means these coefficients have to be the same, which means these have to be equal. And if these are equal and I divide them, it equals 1. Let me give you a slightly different system. Let's say I still had ax minus 3y equals 21, okay? And then I had bx minus 6y equals 11, okay? They're parallel. I have no solution, right? And I want to know what's the value of a divided by b, right? Well, these aren't the same anymore, are they? Can I make them the same? By doing what? I can double it, right? Multiply it by 2. So then I have 2ax minus 6y equals 42. That's non-sequential, not non-sequential, insignificant, okay? I don't care about the 42. I still only care about the coefficients. That's it, okay? Well, now these are the same. I've achieved that first goal. Those coefficients are the same, which means that these two things also have to be the same. 2a has to equal b. So it's not the same relationship that we had here exactly, but it's still a relationship between 2a and b. Okay, I know that they have to be equal. So I can then use that understanding to answer whatever follow-up question they have in relation to these values. Okay, whatever question they want me to solve with a and b, I'll be able to find that information. Okay, I know that these have to be the same. All right, that's what I want you looking for with the coefficients. Don't spend your time rewriting these in slope-intercept form. Be able to compare the slopes with them in this form. It wouldn't be 1 because you're not dividing it by itself. You're dividing it by half of itself. Well, actually, you're dividing it by twice itself. Because I want to know what's the value of a over b. Before it was 1 because a equals b. It's not true anymore now. Now it's 2a equals b. Okay, so it'd be some other kind of setup of trying to compare the values together. Before we figured out that a equals b, so if I divide them it equals 1. In this case, 2a equals b, so they would have some other setup to allow us to compare them. That makes sense? All right, questions, comments, concerns, queries, conundrums? No, this would require something else that I haven't thought up on the fly for how it would be. I just wanted to show you that relationship. If we wrote a different equation where these weren't already the same, and then manipulating it so that they were the same so that we could then make this comparison. Okay?